Hi guys, I hope you're having a good spring break. I decided to make a quick video to go through problem number 7 with you. Now that you've had some time to hopefully try it on your own, I'd like you to watch the video to make sure you did it correctly, and also to just hear it explained one more time, and hopefully it'll really kind of sink in the more and more we practice these. So I've done the first step here. I've written our rate equation. Rate equals K times our first reactant, and we can call that X, and then that's times our second reactant. We can pretend this one's to the Y, and we're trying to figure out what these numbers are, and generally they're going to be either a 0, a 1, or a 2. And we have to use our data in order to figure that out. Okay, so if we want to figure out what the order of X is, we need to look for two trials in which Y is not changing. And I see these two here, the last two, where Y is not changing at all. Okay, when Y is constant, now we can focus on just X. Okay, and it looks like between those two trials, X is doubling. You can put the first one in your calculator and do it times 2, and you should get the second one. So here, the rate, or the concentration of X doubles. Now go over to the last column and look what happens to your rate. It also doubles. The first number times 2 gives you the second number. So when they do the same thing, your reactant concentration doubles and your rate doubles, that's a first order equation. Okay, let's do the same thing to figure out Y. We need to find two trials where X isn't changing. It looks like the first and the third X are constant. The number is the same in the first and the third. So let's look at those two trials over here. If you do the first trial to the third trial, it looks like the number is doubling. What happens to the rate? Oh, that number doesn't change. When that happens, when a concentration is doing something, but the rate is not affected at all, that's a 0 order, because it's not changing one bit. So in this one, you should have X is a first order, Y is a 0 order. To get the overall, you just add those numbers together. If we're going to rewrite the equation, we're going to write rate equals K. We know that our NO2 is now raised to the first, and our O3 is raised to the 0. Actually, anything raised to the 0 is going to be 1. So no matter what we plug in here, it's not really going to affect our equation. Let's go ahead and go to our next step. We're going to plug in the data from one of our trials. So let's just plug in the data from trial 1 to keep it easy. It says the rate, 0.088, equals K, that's what we're trying to find, times the concentration of NO2, which is 0.0001, 00 if you want to put it on the end. Make sure you're recording all your numbers, and times the concentration of O3. Same thing, 0.00000, I think that one has 4 zeros, to the 0. Okay? Like I was saying before, anything to the 0 is just 1. So we can kind of eliminate that from our equation to keep the math easy. We need to solve for K. So if you want to get K by itself, you should be bringing this number down here to the bottom. So your equation is going to look like, I'll rewrite it over here, 0.088 divided by 0.000100, and that equals K. So that's just rewriting this down here, move to the bottom. Let's put that in our calculator. you should get K equals 880. Okay, to rewrite your whole answer, it's just going to be rate equals 880 times the concentration of NO2 to the first times the concentration of O3 to the 0. Okay, so it's the same steps that we did in our problem number 6, but we're just using some different numbers. Again, I would say the hardest steps are step 2, really thinking about what these two numbers should be, and then obviously step 4, getting these numbers plugged into your calculator correctly. To solve for K, you are always moving your concentrations to the bottom. They get divided. So please, please, please practice punching this into your calculator until you get 880. If you have any questions, please feel free to email me or give me a call or text me so that I can help you before we show up in class next week. We will have a short quiz over this rate stuff, so make sure you're looking over your homework before you come to class. Thanks, guys. Have a great rest of your break.